Okay, we finished, I know we jumped around a little bit. We went to chapter 12. Now we're jumping back to chapter 10. Chapter 10 is starting to get into some of those different functions that you see on those standardized tests as well as the ACT. So they are very important functions and equations, things like that, to feel very comfortable with. Algebra 2, there'll be a lot more in. So this is just kind of giving you a taste of what Algebra 2 is going to look like. So today what we're doing is we're going to do a square root function. Square root function, we all know, or hopefully know, what the square root looks like. So this is a square root function. It has a little notch there, so it's not just a regular divide. We have the little notch there saying that's a square root. Okay. With that is what we call a radical function. We could change this, and there could be a 2 there. Could be a 3, because that's a cube root. Fourth root, things like that. So if you see those, don't just panic. You know that this is a cube root. So when there's a little 3 right there, that's all it's saying is it's the third root. Okay. So what we're working with today is a square root, and we're looking at the radical function. So this is an example of the radical function. So we have the square root of x. It doesn't have to just be a square root of x. It could be square root of x plus 3. That's all inside the radical. And then plus 5, and we could have negative 7 out here, and that equals y. So this could be our whole function right here. So y equals negative 7 square root of x plus 3 plus 5. So that could be an entire function right there that we're looking at, the radical. The stuff underneath the square root is what they call the radicand. Okay. If I'm looking at the basic square root of x, and I want to graph that. So the best way to graph is kind of, we pick out some points and we figure out what the x and y is. So we put in 0 for x, we get a 0 for y. So 0, 0. We cannot put in any negatives. Negative numbers do not work underneath that because everything we do is in the real plane. Square root of a negative is an imaginary plane, so that does not work. So all these are going to be eliminated. So all these negative x's over here are going to be eliminated. So we put in 1. Square root of 1 is 1. Put in 4. As you see, I'm picking nice numbers. So square root of 4 is 2. 9 is 3. Okay. So what it looks like an arch. Okay. Kind of a poor design of it. Use the big dot theory. Make sure you get the dots on there. Okay. So it's going to be a nice arch is what it's going to look like. They have a better graph in the book. So it's going to be arcing up. If we're looking at this for domain and range, for the domain, so we ask what is the x? X such that x is greater than or equal to 0. So that's what we're looking for there. So x such that x is greater or equal to 0. That is our domain. Our range is y such that y is greater than or equal to 0. So this goes on without bound, and it will go all the way up. It'll keep growing without any control. So we're looking from 0 to infinity and 0 to infinity. That's really what works for the domain and the range. I take this. You understand the domain? So I take this. You want to say domain is equal to that. Range is equal to that. I understand that. The first way we do it is that the little more math formal way. So either way will work and is acceptable. So next thing they ask us for is graph 2 square roots of x. So they're just going to change this a little bit. Just put in a 2 right here. So 2 square roots of x. And they ask for the domain and the range. Okay. So once again, we're going to choose nice numbers. We don't want to make it really confusing for ourselves to try to figure out what's the square root of 2. So we put in 0, we still get 0, because 0 times 2 is 0. So I put in 1, so 1 times 2 is going to be 2. We still want to use a nice number like 4. So the square root of 4 is 2, times 2 is going to be 4. Look at 9, square root of 9 is going to be 3. And then 3 times 2 is going to be 6. So now we're kind of seeing that nice arching motion there. And that's what a square root is going to look like. It's going to continue to grow, without bound, it's going to keep going up. It's going to have an arc to it. Okay, so that's what it's going to look like. They asked for the domain and range. So the x such that x is greater than or equal to 0. And the y such that y is greater than or equal to 0. Okay, so that's really what we're looking at. Sorry, so looking at that there, that's our domain and our range, and we're good there, right? And we see that with all those. We look at check your progress 1A and 1B. Domain and range on those are going to be the same thing. There's no shifts on them, so that's why it's going to be from 0 to infinity and 0 to infinity. Next thing we're going to look at is we're going to change this up a little bit, kind of like I showed with the first example. So the first example, we look at y equals a square root of x plus h plus c. Okay, the h is inside the square root, the a is outside, and the c is outside. So we're looking and saying, well, what's going to happen? So if we change the a, what's that going to do? What's going to happen if we add an h in here? What's going to happen if we put the c? And so that's what the next examples are looking at and saying, how does it shift it? Okay, so the first one that they want us to do is y equals -3 square roots of x. And they want us to graph it. So we're going to do the same thing that I just did. And can't put in a negative. There's no negative numbers that will come out of that. So 0, 0. Put in 1. I get -3. 4. -6. And what we're seeing there is it's going to start arching that way. Big dot there. So it's going to arch that way. So any negative there is just going to mirror it across the x-axis. So we see a negative out front of the square root, we're going to mirror it. So now the domain and the range, okay? So x such that x is greater than or equal to 0 is still going to be our domain because we cannot put in negative numbers in that. Our y is the one that's really changing. Y such that y is less than or equal to 0. Okay, so there's our domain and our range. So x is greater than or equal to 0, y is less than or equal to 0. You know everything's going to be down here. And once again, we still cannot have the negatives. Cannot take the square root of those negatives. Looking at example 3. Example 3, the first one is the square root of x plus 1. So, and the plus 1's outside. So we're looking at that c. The first one we changed our a. Now we're looking at the c part. So it's square root of x plus 1. So I put in 0 for the x. I get 1 for the y. So that's going to be my starting point. I put in 1. I'm going to get 2. I put in 4. I'm going to get 3. Put in 9. I'm going to get 4. And there's what it is. So by putting that plus c, that c is just shifting us up 1 unit. So now, instead of our x, it's still going to be x such that x is greater than or equal to 0. So we can still put in the same points. We're still working with that parent function there, the square root of x. Now the y, once again, is going to change. So our range is going to change. Y is greater than or equal to 1. Because we have a 1 here, nothing below 1, so it's 1 and above. We want to make sure that's equal to, because it does equal that. Okay, part B, now we have the square root of x minus 2. That x minus 2 is a quantity under the square root sign, under the radical sign. X minus 2. Okay, so I go x minus 2. I always put a little bracket on there so that way I know, because I have such horrible handwriting. So I kind of bracket that off and say, this is where my square root ends. So that way stuff doesn't bleed together, or I don't extend my square root far enough. So if you see me writing that, that's all it is. It's just saying, this is where I stop. This one here, we have to look for that 0. Okay, So I look at x and I say, well, can I put in 0? 0 minus 2 is -2. Oh, can't take the square root of negative. So it looks like my first point is going to be at 2. So I put in 2. 2 minus 2 is 0. Square root of 0 is 0. So then I put in 3. So 3. Then I'm going to put in 6. And then I see that same graph coming up again. So what I look at this and it says, well, now my y is going to be the same. My y, such that y is greater than or equal to 0. But my x has changed because now I'm changing that parent function onto the radical sign. So x has to be greater than or equal to 2. So there's my domain and range for those. So x is greater than or equal to 2 because that's what's underneath the square root. So everything's just shifted. So I shifted it right. So if we change h is a shift right and left. C is a shift up and down. A just changes really our amplitude. A is pretty standard for amplitude. So it changes how fast do we grow, how slow do we grow, or how much is it stretched out. And then if we flip it upside or down. Okay? So that's kind of what those three are. So with this, once again, shifts us up and down. This shifts us right and left. This changes how fast we grow, or if we go up or down, if we mirror across the x-axis. Okay. So that's really what we're looking at there. Looking at real world example number 4. Golden Gate Bridge is about 47 meters above the water. The velocity v of a free-falling object that has fallen h meters is given by v is equal to the square root of 2gh, and g is the gravity in meters, since everything's in meters here. So it's 9.8. If it was in feet, it'd be 32 feet, but this is in meters, so it's 9.8 meters per second squared. Graph the function and obtain the dropping in front of the bridge. Okay, velocity of the water. All right, so we look at this one here. They gave us the equation. V is equal to the square root of 2gh. Okay, so with this, they gave us some other information. They told us g is 9.8, so v is equal to the square root of 2 times 9.8 times height. The height is 67. Now you see why I extend that on and I put a bracket behind it, just in case they haven't if they added something on. They're not adding anything on, so we're all right. Okay, so we plugged it in. Now we need to do the square root of 1,313.2, which v is approximately equal to 36.2. Which v is approximately equal to 36.2. So in this, it depends on how you have to type your calculator. If you can type a string in, you'll want to go square root, parentheses, so that way it knows that this is a group. Okay, so that way it knows this entire group needs to be square root. If you cannot type in a string, so if you have a basic calculator, you got to go 2 times 9.8 times 67. You get the number there, then you hit the square root button, and the square root button should look like square root of x, I would guess, on your calculator. It just could be a square root button as well. So you have that number, you hit the square root button, and it gives you the answer. It should be approximately that. Okay, so make sure that you can get this answer. Check your calculator so that way you know what you're doing when you're doing the problems. Okay. Very last one. Transformations of square root functions. Graph y equals -2 times x plus 1. Y equals -2 times square root of x plus 1. Okay, looking at this right away, as we just pointed out a little bit ago, there's no h, so there should be no left or right shift. There is a c, so there's a vertical shift. And there's an a, so that mirrors us, and it's a negative a, so it mirrors us. And it's going to be happening twice as fast. Okay, so what do they want for this? Compare the parent to the regular. Okay, so the parent, you know, looks kind of like that. Okay, this one here, 0, 0. I put in 1, square root of 1 is 1, times negative 2 is going to be negative 2. Negative 2 minus 1 is going to be 1, negative. Now if I put in 4, so square root of 4 is 2, times negative 2 is going to be negative 4, minus 1 is going to be negative 3. Okay, so I'm just showing that it's growing a little bit faster. It's mirrored across the x-axis. Okay, and that's good enough. But they do ask for the domain and range. So x such that x is less than or equal to 0. Oops, no. Thinking the y. X is greater or equal to 0. So it's the same thing for the domains. Y such that y is less than equal to 0. Okay, so I know that it has to be less than 0. There, that's what we're looking for. So really the difference in the domain and the range is just that little sign right there with these two functions. Oh crap, should have been shifted. Ah, messed up. So I'll put in 0, should be 1. Right? Should be a 1, 0, 1. Doesn't just give me a 0. I put in 1, negative 2, and then that gives me negative 1. So it does shift me a little bit. So it is a little bit different, duh. Because like we said right going out, is this is going to be a vertical shift of 1. So I know this should have went up 1. Okay, so there we go. All right, that was example number 5. So, if you don't want to just plot the points, go ahead and make the table. So you know you want nice points 0, 1, 4, 9. Those are nice points. We do have to watch out if we have that plus h in there, because that will change our x points. Because if that's a 1, now we're going to have to add, or we're going to have to subtract 1 from those. So keep that in mind. And whatever it spits out, then plot the points. All right. You have any questions? Let me know.